Okay, welcome everybody. We are going to start in about a minute. Let me just notify the people of the channel that we are live. Okay, welcome everybody. This is another session with the Learning Ambassadors. My name is Martin Sindifon, and co-hosting with me are two other Learning Ambassadors, um, Sipamandla and Anthony. Please, Sipamandla and Anthony, you can introduce yourselves.
Hi everyone, like I said, Michael has introduced me, Martins. So my name is Pamandla Machian, and then I'll be helping out with anything that you guys are having, okay, for the printf project.
Mr. Anthony.
Okay, so as my host has introduced me, I'm Anthony Ebo, and I'm from the cohort 13, and we are here to help you through your printf project.
Okay, so I'll be your main host for today. Other sessions will be hosted by my fellow Learning Ambassadors. So we're going to jump in right away. Today we have three agenda. We're going to first do the collaboration, how to effectively collaborate, and then we're going to jump right into Variadic functions. And then lastly, I'm going to show you a little step on how to begin writing your own printf if you haven't already started. So to begin right off, I have the presentation ongoing here. So, okay, yeah, disclaimer. We were told, we were instructed not to show our GitHub profile. This was supposed to be live, but we were instructed not to show our GitHub profile for cheating reasons so that people don't, get our GitHub names. So I apologize for using a presentation style to show you how to collaborate. But if you have any question, you can always reach out to me on Slack. So most of you have already had some questions this morning, which have been answered on Slack. But I'm still going to go over this. So once you create the repo, and by the way, only one repo should exist between between a team. So there should be no more than one repo. Only one repo should exist between a single team. One person should create and then invite the other person as a collaborator, as you can see here. So you just invite the person as collaborator. You add either their email or their name or their name on GitHub, and you can send them an invite. The other person will receive it on their email and accept that invite. Once that's done, you now clone the project. In the project description, it is written that you should not fork or clone. I know that's like a little bit of confusion, but what they're trying to say is do not fork, basically. So the preserve project or the repository should not exist on both of your profiles. So you want one person creates the other person join as a collaborator, and both of you fork to your terminals, and then you start working. So once you start working, you first of all have to do the base directory. So there's going to be the master directory. So you can see in this master directory, I've initiated it with a README, just a test README for demonstration. And then I pushed that README to the hub. So both of us can now see that. Then when I wanted to start working, I created a new branch called tax 0, as you can see here. I created a new branch called tag 0. You know how to create a new branch, just git branch on the branch's name, and then you git checkout into the branch, and then you work from that branch, just so that there are no conflicts. You want to spend time doing the project rather than spend time resolving conflicts. So you work from that branch, and then when you're done, you push to that branch. So you can see here, this is after I had pushed to the branch. And then you can see this compare and pull request. So this is where you now create a pull request so that your teammates can review and then merge the pull request. And if your teammate also pushes from another branch, you will see the pull request. Once you guys are ready to merge into the master branch, the master branch would only hold code that works. So anything you are testing, any new tasks you're doing from another branch, and you guys have to keep in touch. So now, once I created this, is where I created the pull request. So now I wrote like an information comment here, and then created the pull request with this button. Please, if you don't understand, just kindly unmute your mic and ask any question you want. So after creating the pull request, yes, so I created a pull request, and now my teammates would now have to accept or merge that pull request. So once I create a pull request, an email will be sent to them, or they can also see it here where they have pull request. You see one, or how maybe there are more than one pull request. You see their number here. So your teammate goes inside there and then merges the pull request. So this is for my teammate. So he has now come to the screen where he can merge the pull request. You can see merge request. He can write a comment, and you can choose not to merge if you change.
Can I step here for a minute?
Okay.
Len Okran says that they can't see your screen for some reason. I don't know.
You can please somebody. Okay. I can see that my screen is sharing from my end. Gabriel, is this problem only to you? Please, somebody else should confirm that you can see my screen. If you can, Gabriel, you have to. It's a bit blurry. I can't see at all. Wow, that's so many persons. Okay, let me just stop sharing and share again. Sorry about that. Okay, let me just share that again. Why is it blurred? Please, somebody should confirm. Sipamandla, can you see my screen now?
Not yet. Yes, I can see your screen now.
Please, other persons should confirm that they can see my screen. I'm going to make this a. Okay, let me make this bigger.
I believe most people can see the screen. It's just that it's a bit blurry for some reason.
Oh
I don't
yeah,
know
because
why.
these are screenshots. Sorry about that. These are screenshots I took from my browser. Please just confirm this page. Confirm that you can at least see like the invite collaborator. See, my screen is on full screen mode now, so I can't see their comments.
So they say they can see your screen, but like you said, you took screenshots, so it's not gonna be as visible as if you're doing the real thing. But yeah, we can see your screen, man.
Is it visible to you? Is it too blurry to you as well?
I can see, but at some point it gets blurry and not blurry, blurry, not blurry, something like that.
Oh, please, if you're using a mobile,
Sorry, Martin.
yeah, go
Yeah,
on.
Can I suggest you put the PowerPoint slide in the slideshow view? Is it possible?
Yes, this is a slideshow view now.
Okay, this is the slideshow view. Oh, okay.
Yes.
but can you actually make it? Can you tap on the full screen mode?
Yes, this is. I can't even see anything else. I'm literally on the full screen mode right now.
Okay.
Please, if you have any collaboration question, please, you can always reach out to me. If it's too blurry, I apologize. We were not allowed to share our screen for GitHub. I'm very sorry about that. Collaboration is like only about 10% of the entire project, so we want to blow through this very fast and go to the main thing. Okay, so as I was saying, you invite your partner with this button. You add them as a collaborator either via email or their GitHub name. And then you create, you fork to your, sorry, you clone to your terminal, whatever terminal you're using, Vagrant or maybe the sandbox. And then you create, make say a README and push to the master branch. But when you want to start working with the tasks, just so that there are no conflicts, you want to create branches. So you can see this is the master branch, but this is a new branch that I pushed, that I created from the terminal, and I worked on that branch. I didn't do any work really on the branch, but I just worked on the tag zero branch and then pushed to the tag zero branch. You can do that with git push origin and then the branch's name. And then you create a pull request when you're done with that, and don't merge the pull request. It's possible for you to merge the pull request yourself, but don't do that. It's basically for your teammates to merge. So when your teammate comes, your teammate can see the pull requests when they go to this pull request tab, or I think they get an email, and then they can merge that pull request once they have reviewed and note that nothing. And GitHub first of all will check if it's possible to merge. If there are errors, GitHub is going to show you and how you can you know be able to fix those errors before you can merge. Once you merge the pull request, you can see this is still the master branch, but what I did in the pull request in the tag zero branch has been added to the master branch. So this is just a printf and main.h. They have nothing inside of them. And then the last thing is, this is very important. This is a Google document that you can create and then share to your partner, add his email, or just send him a link. And both of you should always keep this document open and refer to this document whenever you want to start working on tasks. You can see I have a template here that says name, report, and status. So if, for example, my name is Martins and Defon, if I'm working on, say, tag zero, I just say the reports here, working on tag zero. That tells my teammates that when they want to start, they should not work on tag zero as well, because I'm already doing that. So they will now go to tag one and then start working. And you can, when you're done with tag zero, you can update the status here to say it has been completed. And you can even write like more stuff here, like I have pushed, you can merge, or you can review and merge and stuff like that. You want to keep this always open. Both of you have access to this. If Google does a beautiful job by synchronizing this on both of your machines. So that's all for collaboration. Does anybody have any question related to that? Okay. If there is no question, I gave 15 minutes for collaboration, but it's 12 minutes, so we are on track. So can I continue, please? Somebody should give me a thumbs up for continuation. Let's go into the main business of the day. Okay, the pull request. Somebody's asking that they don't understand the pull request. Please, you can do a very small Google search to understand how pull requests work with your. It's just it's won't let's not waste time doing that. Or you can just watch single YouTube video and you understand exactly how working with your partner using pull request to work. Caroline, you can create this Google Doc templates yourself. You just create a new doc and share with your partner. You guys can. I would send it to you. That's no problem. I think I have it open somewhere here. Yeah. So Caroline, you wanted to say something. You can do that.
Can you hear me?
Yes, I can hear you now.
Okay. I was asking about since it's one task, printf project,
Yes.
do we just create a repository of it because it's one task?
Okay, you
And
first
we
of
will
all
not
create.
sorry.
You would create your repository, right? Just
Yes.
one repository. Only one person from the team should do that. It's one person's responsibility, not both of you. One person creates and then add the other person as a collaborator. That's all you have to do. And then both of you can work from your terminal individually and then push to that repository.
Okay.
Yes. So please, if you don't understand this entirely, you can always message me on Slack. Is my audio distorted? Somebody said my audio is not very clear.
It's okay on my end.
Okay. Cabello is saying the file names can. We are going to see that shortly. Yeah, you can name your files anyhow you like. Audio is fine. Okay, let's continue. So the main business of the day, Variadic functions. Variadic functions are very, very important because they allow you to um, take in a variable number of arguments. Normally, in regular functions, you have to like define the arguments that that function would require. So if it's going to require two integers, you would declare it like that. This function requires two integers, and if you pass more than two integers, it's going to raise an error. But with Variadic functions, you can pass in as many integers as you want, and and it will work with all of those integers. In higher level languages, this is very easy to do, but in C, we have to use something from the standard arguments library to be able to do that. So Variadic functions in C are functions that accept a variable number of arguments. They are a powerful feature that allows you to create functions that can take a variable number of arguments based on specific use case. Variadic functions are commonly used for functions like printf, scanf in C, and these functions accept a variable number of arguments. That's why you basically need it. But any function you can decide to create functions that would accept a variable number of arguments, like you will see in maybe Python or JavaScript when you start working with those. In C, variety functions are implemented using the standard arguments.h library, which provides macros and functions to work with variable argument lists, as you are going to see shortly. A variety function adds flexibility to the program. It takes one fixed argument, and then a number of arguments can be passed. So it has to take one argument fixed. That's why when you're using printf, there needs to be one string, and the argument printf uses is a string. The one argument has to be a string, and then you can pass in a variable number of arguments. Let me just make this full screen again. I forgot about that. Okay. So the declaration syntax is, first of all, you have to include the standard argument.h library so that you can be able to use the var all the macros from the library. And the declaration is, obviously, you have to start with the return type of the function. Whatever it returns, it doesn't have to be an integer. In this case, this is just an example. And then here it returns, and here's the name of the function. And then here is that one argument that it must take, the last passed argument that it must take, and then the type of the argument as well. And then just comma and ellipsis. The ellipsis stands for the other variable arguments. You must have seen this before now. So there are a few methods that you can use in this standard arguments library. First one is the var list. This is the type that holds the variable arguments. So all the arguments that are going to be passed here are going to be in this type var list. And you can name this anything. It's just conversion. Most times it's just AP everywhere. So this AP now will now hold all of these arguments that you have passed in here. And then you now have to start, and this is how you go through. You do var list, you do var start. Once you start, var start takes two arguments. The first one is the var list argument that you've created before, and then it takes the last parameter of maybe like counts now, for example. That's the last parameter that was passed to the function. So I said the description is initializes the var list with variable arguments, where the last parameter is the last fixed parameter.
Yes.
If you don't understand, please, you can always ask a question. Var_arg, which is another method that is going to be used. Var_arg is used to go on.
Sorry to interrupt you. People in the chat say they can't see your screen. It's stuck on the first page of the Variadic functions.
Whoa, that's I didn't want to make this full screen. Let me check that myself.
Yes, I believe they can see now.
Okay. So you can see the methods now, yeah? Okay, let's leave it like this. So I was saying var list and then var start. Var list holds the variable arguments in the variable you created AP, and then var start takes in that AP as the first argument and the last known parameter that you pass to the function, which is in our example here, count. And then we move into var_arg. So var_arg also takes the first argument, which is that var list argument that you've created called AP, and then the type of that argument. So if it's a char type, you have to state it here. If it's an integer, you have to state it here. like that. But var argument will retrieve the next argument with the specified type. And then var n basically cleans up the var list object that you created when you started. There's also something else called var copy, which I don't think we're going to be using a lot or even in this project. But the var list argument will make a copy of variadic function arguments. So I don't think we're going to be using this. I just added it here because it's part of the method of the standard arg library. So please, we're done with that. We have to write some code now, which is the most interesting part. Whatever you didn't understand, you're going to understand now. So I'm just going to stop sharing the screen and share the screen to my terminal. And we can start writing some code. Yes, I'm no longer sharing my screen. I want to share a different screen now. So don't worry about that. Just in a few seconds, you should see my terminal. I've made it very large. See, once you see my terminal, please kindly just confirm. Okay. Please, if you cannot see my screen, leave the meeting and join again. I think that's usually the best method. Who would like to speak? Please go on. Okay, most persons can see my screen, which is great. If you cannot see my screen, just leave the meeting and then join again. I think you should be able to see my screen then. Okay. Let's just get into that. So this guy is empty. And let's create, say, an example called sum.c. Right, let's use variable arguments to just do an example. Just one example for now, and then we'll continue. Sipamandla, you can see my screen, yes?
Yes, I can see your screen clearly, but Rennie John can't see your screen on the chat. I don't know for what.
Yes,
For
if you
those
can.
who can see the screen, I think you need to tap on the icon, his name here, because that's what I did. So I couldn't see the screen earlier.
Okay, yes, please
Like
go
tap
to the list of past participants, and you should see the screen sharing and just tap on it. It's supposed to be default for everybody, but if it doesn't work for you, that's one way that can make it work. So is the font big enough, or shall I increase it?
I think it's fine.
Okay, is it fine for every other person? Okay, I heard the thumbs up notification sound. All right. So now we're going to start writing some code, and I've just included the standard IO so that we can just print something that's what that one is doing there. And then now, like we saw in the explanation, we have to include the standard arguments library, right? So we just include that, and we can start writing. For this demonstration purpose, I will not be writing documentations just to save time. So I'm not writing any comments, just to save time. So we're going to declare this function here first. I'm just doing a simple summation function for now. So like we saw before, the variable arguments just have to be 3 or an ellipsis or 3 full stops. Then that's all for our declaration. So we can now write our main. We can also write the function first for the main, but I just like writing main first. And then now let's say we will have to call that function, and that's our main. And then we pass in how many arguments that function should take, say 5. And we pass in the rest of the arguments that we want to sum. And obviously this function is going to return us the sum. So we have to save that. We have to save that and if we're saving that there, we have to initialize, declare that variable. So after here, we just print the sum. So we're using printf here. The first argument to printf is a %sign. So we all know. And we print res. Res is short for results. I like using res a lot. And we return 0 because our function is returning an integer. So for the main function itself, following our declaration, we now initialize it. And here, the count will just hold the number of variables that we pass into this function, right? It's the last known argument again. And like we saw in the description in the PowerPoint, we always want to start with your var list, right? Your var list will now take in all the arguments. This was exactly how it was in the PowerPoint in the presentation. So you start with your var list, and the next thing you want to do is your var stats, because now you have all the arguments inside that AP. So you now do var stats to start. This is how it will always be. Var list, var stats, probably call some var arguments, var end. Always. So the var stats, like we saw, takes in the AP or the var list arguments as the first argument, and then the last known argument, which is count, that we've passed in. Hope I don't miss semicolons. And then we are doing summation, so we have to hold the sum variable. Let's not use sum. Let's use like total, and just initialize that to 0, and we have to create it now. Sorry for doing this stuff. In Python, you don't have to write int thing, and I'm used to that. So we come here to total. Now we have our total. So now we want to iterate through this entire list and sum them up. I think there's an error here. So want to iterate through, yeah, they can even stay with spaces. Want to iterate through all of this, all of the variable arguments that we'll get, and then want to sum them up. It's as simple as that. That's all we're doing. So to iterate through, obviously, we have to use a for loop. And we say I, but I have not. God of mercy. So we put our I there. It's okay to be doing this actually. Declare variables when you want to use them. So you don't declare variables you won't use that would raise errors. I equals 0, I less than our count, because the count will hold the number of arguments that will pass in here, and then I plus plus. Semicolons everywhere. So now we want to say total, because total is 0, and we want to add the first argument. We can say total is equal to, total plus the first argument in the list. In this our for loop. So every time we iterate through this loop, the next argument will be added to the total sum. So we can say total is equal to total plus var plus the next argument. Let's not say var add now. And to write that, the short, I think, let's just use short form. We should be comfortable with this. Total plus equal to is the same thing as writing total is equal to total plus something else. So now we call our next argument, which we have to use the var arg now, like we saw in the presentation. So we're using var arg, and our first argument here has to be the var list object. And then the second argument is the type, like we saw. And since we're passing all integers, we can just do int here. Semicolon, not to forget. So once this loop finish iteration through, we will have the total number. Remember, total is declared outside, so total will always regain its value. If you declare total inside this for loop, this won't work, because total will be reinitialized to 0 every time, and you probably have just the last 5 as the result. So once we're done with that, we return total. And I think that is actually all. We have to compare to know if we made any mistake. So yeah, we didn't make any mistake. And we got 15. I think the numbers I passed were 1, 2, 3, 4, 5. That's 15. So just to be sure that this works. So now you see how these variable arguments work. I'm going to do another example and then move over to the printf just so that we are very, very clear. Let's say that's 15. So if we add 1 here, it should give us 21. So we add 6. This should print 21.
Martin, sorry to interrupt you. Hassan in the chat is saying that you are fast, so please explain
Oh,
the concept slowly so that we can
okay.
understand better.
Sorry about that. I am trying to actually beat up time because we still have like a couple of things to do. You can always, there'll be a recording. I hope that is streaming to YouTube live. Hopefully, there will be a recording. You can check. See the link I sent to you. Check if it's streaming on YouTube so that we know that we have it and we're done. I'm going to do another example just so that we can go through this again. The example is going to look almost like this. So, yes, first of all, I said this will print 21, but it's still printing 15. And I could have said you should tell me why, but we've gone too far in C. So it's still printing 15 because the number of arguments is still 5. Meanwhile, I increase the number of arguments to 6. So it's iterating through the first 5. Yes. So I think somebody wanted to say that. So if we change that to 6 and we run again, we should get that 21. So don't worry about that. Let's create another function. And just to save time, I am going to start from this one I have just created and call this maximum. I'm going to be slower now. Oh, geez, not that. Maximum.c. And let's remove that maximum that we created before. Now we are into maximum.c. So we're just starting from here. Let's just change stuff so that we don't have to type too much again. I'm going to go over this again, so please just bear with me. Okay, so let's start again. For those that did not understand, I'm going to be slower now, hopefully. So this is the declaration of the function. So maxnum, it takes in an integer, and then the declaration does not have to have the variable name. It can just be int. That's still fine. And then the ellipsis, which is a normal declaration if you want to use a variable number of, or this is the normal declaration of a variadic function. So that's basically that. String cost. Somebody else's fellow Gista, you want to say something? Your mic is okay. Not anything. So we want to start this new function again. Maxnum. I thought I changed this though. We have to change here as well. We're calling maxnum no longer sum. So this is supposed to print the maximum number. Let's just change this to like 23. It's supposed to print the maximum number from these numbers. So yes, we print rest. That's all right. Here also we want to change this to maxnum because the function name has changed. And then now this is going to be like a little bit different now because we're writing a different thing, but the idea is the same. For the person that did not understand, you start, once you want to use a variadic function, you start with a var list. The var list object is coming from something is wrong with my mouse. The var list object is coming from the standard arg.h. And we start with var list. Plus this is how we always start. Var list, var starts. Oh, geez. In the other function, I did actually use var end. Nobody reminded me. Once you are done, you are supposed to use the var end. And it didn't even fail. I don't know why. This is a var end and pass that var list object, which is crazy why it didn't fail. I think C or the compiler I'm using does that automatically. So you do var list, var starts, you probably use var arg in between the var starts and the var end, right? That's just the format. It's going to be the same every time. So you don't have to even worry about that. So now for this our new algorithm, the project we're doing, Remember, I want to find the largest number. So here I'm just going to assume. Let's not use total. It's not going to be part of us. I'm just going to assume that the maximum number right now is we call in our var arg, and we do pass in ap and the type, right? So we're assuming that the maximum number is that first integer that we will pass to this function. Let's declare max. And then we do the looping again, which is going to be the same thing. Okay, since it can be the same thing because we've already called the first argument and given it the max. So we want to start from 1. Or you can start from 0 and just do less than or equals to count minus 1. It's the same thing. So here now we will now call the next argument. Right? Let's just call it num and call the next argument to check which is greater. If num is greater, we make num max and that's all. So we're calling the next argument here. And then here we're checking if this next argument that we have called is greater than our maximum, the maximum that we already had. We want to do something very simple. It's my arrow key. Okay. And so we want to now make max is equal to num. Let's just remove this line here. So basically what this is doing is we say the first argument is the maximum. We just assume. And then we now call the next argument and then check if that next argument that we've called is greater than our first argument. If it is greater, that means that argument is the maximum. We iterate again to the next one. We say if the next one is greater than the one we just called, like that till the end. So in the end, we should have our max number. We have not declared. Okay, so hopefully there's no error anywhere here. So here we're using var end. Don't forget to use var end. We cannot return total. We have to return max because that's what we're getting. So here now the result from max num will return the maximum number to res and we're printing res. So this should work. Oh, okay. So you see it returns the maximum number which is 23 and we can and we can change another number to maybe something larger, 334. And we get that there. So now we are moving to the printf, which is very important. We've known how to use variable arguments with common integers, but yeah, so printf, how do we now translate that? So printf, I want to now show you how to this is not me doing the printf project. This is just me showing you how to start your printf project in case you don't know how to start. So I'm just giving you a small step of the way to, just try something. It's not even the best implementation. I can see somebody's. I hope you can still see my screen because somebody else's screen is popping up in the middle of my presentation. Somebody else's video. Please, if you can see my screen, just a thumbs up. Let me confirm. I see no thumbs up. Sipamanda, is everything okay? Okay. Okay, there's a thumbs up now. All right. So the main thing for the day, I'm going to. What did you say?
I said everything is okay.
Okay. So I'm going to call this printf.c, and this we're just going to do a small, very, very little implementation. And before that, I've prepared beforehand 2 things. So let me just get my main.c to this directory. So in the main.c, you can see that I have just prepared a small main.c to test what we're going to do today. So there is using our own printf and then using the standard library printf. will print exactly the same thing to see whether they return the same thing. And this is a way to test your printf function. So you use yours, use the standard. You use yours, use the standard. So for this example, I'm going to be printing integers, character, and a string. Just the three most popular types. That's what is in our main.c. Also, I prepared two other things that you should already have, so we don't have to waste time and focus on the main thing. I have a write functions. I prepared something called write functions. And in our write functions, we have put char and put, just so that we don't implement them ourselves. I don't want to, I still, because you cannot use the standard put char and put s, you have to create yours. And it's very simple. The put char is just one line. In my previous cohort 16, I created a more optimized put char, but it doesn't really matter. This is just the regular put char with one line using the write function. And then this is put, which still uses put char, but it iterates through the entire string and then prints the strings character by character. So this you should already have. We don't want to do that, so I'm just bringing those here for now. So let's start with writing our very, very low printf, low level printf, very low level printf. Okay, yes, I like doing this thing where I include only the main.h. Why did it not show syntax highlighting? Yes, I made it Variadic.c. Okay, so let's just create the main.h first. I only put main.h inside. So in my main.h, this is where I include everything. So I don't bug my other files with lots of include statements. So inside main.h, I'm going to include the entire libraries I'm going to use, not holding back to anyone at all. So standard library, of course, you want to always have standard library. Okay, yeah, because we want to use prints, the regular printf in our main function. So we have, what else? Sorry, not standard library, standard input output, standard IO. So, okay, we're going to be using standard ag that we already know.
Standard ag. H.
Yes. The person talking, I can hear you in case you did not know. But thank you for the observation. Since we're using the write function in our put s, we have to include unit standard. And what else do we need? I don't know for now, but let's just include standard library. It's usually like very important as well. Even if we don't use it, this will not be a problem. And we can now do our include guide. All right, so we start with the write functions. We have some write functions there that I think there were two of them. Put char one was very important there. If you don't know how to do this, you can always go back and check the put char declaration or definition so that you see the declaration. Then we also have the underscore put s. This is how it is declared. It doesn't return anything. Takes in a string. And what else? Okay, our printf itself, which would this time now is not integer. You see, we have to like the last argument in our printf is going to be a string, not an integer, which is good. We did not put a return function, so our printf will be returning an integer. If you didn't know, printf returns the total number of the characters it has printed. So printf does not return void. It's a function that returns a particular number. And if you look at our main file, you will see that I'm saving their return functions. Normally, you will not want to save this, but I'm just using it so that I can get integers to print. So printf will return the length of everything here, the length of the entire string. So that's what I meant by that. And ours have to return that as well. So what next? So we can now move on to building our printf. So now we don't have the main.h. We don't have to include anything else. If anything is missing, we just include it in the main.h and we can move on with whatever we're doing. Again, I'm not going to write any documentation. Documentation will usually go there. We just start defining. We have 15 minutes. God help us. So if you don't understand, like, hopefully the recording will be available after now. So this is the format here can be anything literally, but this is I think this is how ALX uses it. It's just a pointer to it's a char style it's like a string. It's type for string. You know that initial string when you're writing printf that you have to like put the string, write printf. The first thing that goes in here is the string. That's what this format is for. Okay, so like always, like I've described before, you want to always start with var list. Yes. The next thing, var start. This is now common. This should be common to us. And the var starts. The first argument is the var list argument, the var list object, and the second one is the last pass parameter to the function, which is format. Now we can start writing whatever it is we want to write. So for this our printf, we know that we are going to be. You know what? Let me just do something under here. Please remind me to remove this. So this is how we are going to call printf normally and say this is a string. So normally this is how we're going to call printf. So I want to use this as a guide. So if you call printf, you would want to iterate through all of these characters and print them to standard output. This is, that's like the basic first thing you have to do. So let's just use a for loop. And again, we have to go and declare I. So I equal to 0, and then rather than using anything like count, like we're doing for the integers, we just want to check until until format reaches a null character. So there's always null at the end of any string, like we should know. So we just check if format is not equal to null. So if format I is not equal to, you can actually write not equal to null, like very much, but you can still leave it as like this. It's still fine. This means exactly the same thing. It's either you write not equal to null or you just say format I. This is shorter. I like it better. And then we increment I. So that's the first step. Inside this for loop. Okay, so inside this for loop, remember that printf can also have a %d or something like this. So we want to iterate through. Again, we want to iterate through until we find %, right? Or rather, we will be iterating if we don't find if we don't find %, we want to do something. But if we find %, we want to do another thing. So if we don't find %, we just want to keep printing the string until we find %. So for this, we can use a while loop. Now we cannot say format while format I. This does not have to not fit. While format I is not equal to the character, the % character now. So while we have not hit this character, we want to do stuff. So what is it that we'll be doing? We want to put char. We want to print the character just like I said. So we want to print the format I, right? That's like basically. So if we come to this t, we check if that is a t equal to %. No, we just print it. Right? That's literally all. And then obviously we want to I++. So now we go to the next one, which is h. And if is equal to %, it is not. We we print it and we go to the next one. So it will continue like this until it reaches the space. Is going to print the space, obviously. and then until it reaches the character. So we now say if while format I is not equal to the percent sign, if it's equal to the percent sign, which is here, the one thing we want to do now is to check what is after this percent sign. So we can have percent %d, percent %s, percent %c, percent capital X, like a lot of them of format specifiers. So we just want to increment I first of all, so that we can go to the next one and check what is that next character, right? So if the character is D, we want to do something. If it's C, we want to do something. If it's any other character, we want to do something. And for that, the best thing I came up with for this demonstration was to use switch statements. So we just use switch statements. We pass in the format I. So now this the format I will now hold, since we're doing I++, we've moved to the next character. So the format I now holds the D, right? So, and you know how switch statements, sorry, switch statements work. So you now have like different cases. If you didn't know how switch statements work, you can like do a Google search. But switch statements will is like a if else statement, but this here now we are using like cases. So it will take like a case, and here we want to say if the case is a C. So if we find a C, colon not semicolon. If we find a C, did I declare I? Nope. So let's declare I. And now another thing I want to declare is like J, just so that I can store the no, not here. Okay. Sorry. So that I can use J to store the argument that I want to call. Whenever we see like %d, there's going to be something that we are going to call, like say count, for example. So we want to call this argument and put it inside here and print it. That's basically what we're doing. So this argument is going to be an integer because we're using %d. So we created a variable J to hold that integer, and then we can now print it. So we're just calling var arg like we usually do. Var arg will be in between the var start and the var end, and it's an integer. So this is just regular stuff now. So now we put that character. Right? Characters are integers basically. The ASCII, every character is an integer. They have their like integer equivalent. So we put j there and we break. This is how you exit from the switch statement. So if the case is this is not if the case is say s, which is a string, we want to save it inside. We can't save it inside j. We want to save it inside a string. So string variable. So we have to like create that string variable. And now we can call that argument. What? We can now call that argument, which is a string. And if it's a string, it's a char star. And we can now use put s since we're printing a string. And we know we have put s from our write functions. And we print the string and we break. That's basically it. And it's always good to have a default case, right? You see, I'm not doing the integer now because that one takes like something. So for this default case, var arg again, ap integer. Let's just if we've not handled a particular format specifier, we just want to print that specifier out. So we don't want to do anything if we don't handle it. So if the case is like say x, we don't have any x here, we just have c and s. So we don't want to handle that at all. So we just print it out and we break. Sorry about that. Then we come down here and let's see. What is the for loop? So for. After the for loop, we obviously want to do our var end. Passing that AP, what's it called now? Character. And we want to return I. If you see, we've been dealing with I. So I is the one iterating through. So every character I iterates over, it will hold the number of, in the end, it will hold the number of characters that it has iterated through. So we want to return I. and then we'll just delete this line. We are not handling B yet, just we'll do that. So let's just check if this is. It is almost impossible, but today I'm on the roll. So we just compile now. Printf. Let's see our write functions because that's where we have our we call this print. Oh yeah, our main function that we have. Somebody's mic is activated and it's loud. Omotayo, your mic is unmuted. Okay, let's run this now and see if. Nope. What was this? Let's go to the first one. Oh, integer printf. Conflict type for printf. Didn't we? What's this? Let's check our main dot. What did I use here? Integer. Let's check our main dot h. There's an integer there. Oh, the declaration is totally wrong. Jeez. Nobody reminded me this. There was no ellipses. All right, let's try again. Okay, now it compiles and we can now check print. Segmentation faults. That's the serious problem. Oh, yes, I think I know what is causing this. So all of these are coming from the main printf. Our own did not, our own failed miserably. Okay, so now, if you remember, when we are printing, so when we're only checking when it is a percent character. We're not doing anything when it is null. So when it reaches the end, we're not doing anything. We're still like going to the next one to check if it's a character, and that will have a garbage value, which will not be a percent sign, which will make which obviously has made our program to fail. So inside our while loop, first thing we want to do before we even print is to check if we hit null. Right, so if format I is null, format I is null, we return I, right? Because we don't want to do anything else. So we have reached the end of the string, we just return the number of characters that were in that string. So it will compile now, hopefully no more. Yes, so now you see, so now we print our own printf, which is always the second one, is printing the same thing as the main standard library printf. So this prints. You see, ours is not printing. Okay, our printf is actually the first one. So the standard library printf prints 39, which is the total number of these characters if you count it. And then ours is just printing D because we have not handled it. So it prints the character correctly, it prints the string correctly with the %s. So that's fine. So now let's handle that a very short time. Let's go ahead and handle that %d. So we just come here and like for this demonstration, but this is not exactly how you'll be doing yours. Because you have to be using like function pointers. So rather than doing switch case statements, you're using function pointers to send this whatever argument you get from var arg to your function pointer that will now print that argument. So we'll not be using switch statements. If not, this is going to be too long. Like your switch cases will be like too long. So for here, let's just break first so that I don't forget it. So for here now, we want to print an integer, but we only have two things: put car and put s. Both of them can't print integers, right? So how are we going to do? If we pass input car here and try to print, it's going to obviously fail. That is going to fail. So what are we going to do? We have to create another function that will handle printing integers, and this is how you are going to do in your own printf. You are going to create more functions that will handle printing different things, printing, say, addresses, or printing things in capital letters, or printing things in reverse, like that. But let's just handle one here which is number. So we'll create a function, the function doesn't exist yet, called number, print number rather, and we pass in that j to it. So we say just print the number for us. That's all. Enter here, that's all. But we don't have that function. So we're just going to print that function now. That will help us to print numbers. So we have to, let's add that so that we don't forget now that I've remembered, there's no time. I mean that h, and we have to add that in here. No, it's not, can't return an integer, it's just printing. So void print number, we pass in the number that we want to print, which is an integer, just put in. Okay, so now we're back to our print number. All we have to do is include our main.h as usual. Again, please pardon me, I'm not doing any documentation. We don't have time. Our time is already out. We just need more minutes to round up. So we're declaring the function that would print the number. So the first thing we want to do is an integer can be positive or negative, right? So let's check if it's negative. And to know if it's negative, we just check if n is less than 1. Oh, sorry. Less than 0 rather. But right now, let's just, in case it's 0, so let's use less than 1. From 0 downwards, we want to handle them inside this one thing. So we put car. Why are we putting car? It's negative. Put car, the negative symbol. We convert 1. We convert the negative number to a positive number by just doing this. You can also do n is equal to n times minus 1 from mathematics. You know that if you times a negative number by a negative number, it gives a positive number. So n equals to n times minus 1 is the same thing as n equal to minus 1 in C, which is great. Now we would have handled that. We now come to printing. So to print the numbers, if you've done this before, sometime like maybe a month ago or so. So we're just checking if n can be divided. Like we want to check if the number is long. So let's say our number is say 1, 2, 3. Let's just write that here. Say 1, 2, 3, for instance. So because we can't just print, we are printing with put car, no doubt, but we can't print the 3 of them. We want to print them character by character. So how are we going to do that? We say if the number is divided by if it's divisible by 10, that means the number is longer than 1. Right? So we want to come here and do a recursive call print number again and pass in the rest of the number. What n divided by 10 would do is it will strip the last digits and then pass in the remaining digits again to these print numbers. So if you call print number again, it will come here and check with 12. Is 12 divisible by 10? Yes, it will strip the 2 and then pass in 1 to print number again. And then it will come again and check if is 1 divisible by 10. Yes, but it's 0.1. So and 0, it will remove the 0.1 and just leave it at 0. And that will be a falsy. And then so we will not call print again. So once we get that falsy, we want to now put car our number. But we can't just put car our number, right? We want to put car the last number. Remember that 12 in this our case, 12 is going to be passed in the second call. 12 is going to be passed in the first call. 1, 2, 3 is going to be passed. We want to print only the last one. So the first time we want to print 1, then we want to print 2, then we want to print 3. We don't want to go and print 1, 2, 3, 1, 2, 3, 1, 2, 3, just like that. So to do that, to get the last number from an integer, we just do modulus 10. That just gives us the last number. And we can't print it like this because it's a number. So putcar would not accept a number. So we want to convert that number into a character by doing plus the character 0. It can also be 48, and I'll show you just in a second why that is. Let's delete this guy here. So if you man ASCII, okay, man ASCII, you are going to see, let's just go down to where are the numbers? Okay. Yeah, look at them here. So if you say you want to print 5, for instance, you can pass 5 to Putzka. So the best thing to do is to now add 0, which is, these are decimals. This is octodecimal hex. So we're dealing with decimals now. So 0 in ASCII is 48. So if you now, and then if you want to print 5, 5 in ASCII is 53. So if you now say 5 plus like the number 5. So in ASCII, if you just print the character 53, it's going to print 5, right? So if you in ASCII, so now if you want to print 5, you say 5 plus 48, which is 0. 5 plus 0, which is like 5 plus 48, is 53, and 53 is 5. If you come to 8, 8 plus 48 is 56, and 56 is 8. That's what we're doing there. I'm printing. So to handle our numbers, we just go back to our compilation and just add the print number, take and print. So now we can see that the D percent D is now working and printing exactly what the standard library is printing. That's 5 minutes above the time. I'm sorry for taking you more than that. But this is an example of how you should start writing your printf. Is you are going to like, you can use this to start, and then maybe next week Monday we're going to be doing function pointers. So I don't know if my teammate that is doing is going to be able to bring in the function pointers here rather than using switch statements. But maybe that will also be doing too much. So we'll just handle how function pointers are going to work, and then you can use function pointers to incorporate into this very simple version that uses switch statements, and you can continue. But this is a way to start. So yes, that will be all for today. Thank you very much. Please don't go. Don't not yet. I have a attached with Len Ambassador, but it's Martin Adifon, Sipamandla Mashiani, and Anthony Ebu. Yes. So please, if you have any question, let's just do 3 more minutes. Yes, the recording is going to be available, but if you have a question, you can unmute and ask the question now. If you have the question, if you cannot unmute, you can leave it in the chat. But if you do have a question and you can unmute, please unmute and ask your question. The recording is going to be available, hopefully, after this session. So, yes, I'm just going to end. I'm going to end the streaming after. If there's no question, I'm going to end the stream now. I'm going to end the live stream now. So, does that mean everybody understands everything that I just? If you don't have a question, please either ask now.
Good afternoon.
Okay. Yes. Good afternoon to you.
Please, I just opened the link now.
Yes.
And it is asking the names of the learning ambassadors who moderated
Okay.
it. Please,
Let
I
me
only know one, which is Martin. I
please.
think that's the one speaking, right?
Yes, yes. Please, every learning ambassador should Machani and Anthony. Please type your name on the in the chat.
Okay. All right.
Just finished typing mine now.
Okay. So it's Martin
Steven.
on Machani and Anthony Ebu. So you see our names are attached with learning ambassadors. So please just help us fill this form before you go. And thank you very much for attending. I'm going to end the live stream now. It's 10 minutes after 12.
Yeah, thank you so much, Martins, for the wonderful session.
All right, Machani, thank you.